Hello friends, I welcome you in lecture number 4 on roots of equations. In this lecture we are going to discuss method of false position, which is another method for finding roots of equations. This method is also known as regular falsi method. In this lecture we will see how this method works and how we can find out approximate root of given equation using method of false position. So the starting point for this method is same as bisection method. First we have to decide the interval in which our root lies. So for that we have to decide two arbitrary points such that the value of function at those 2 points is of alternate sign. For example, suppose our graph looks like this. Then we can see that at this point value of function is negative. Suppose I denote this point by x0, and at this point at x1 value of function is positive. So our root lies in between x0 and x1, and this is the graph of y equal to fx. So in bisection method also we decide 2 points by trial and error such that function is of opposite signs at those 2 points. So here also first we decide 2 points x0 and x1 such that if f of x0 is negative, then value of function at another point is positive. Now in bisection method we consider first approximation as midpoint of this interval, but here in method of false position what we will do is we will consider the line joining these 2 points. This point suppose denoted by capital A, so its components are x0 comma f of x0, and this point is denoted by say capital B, then its x component is x1 and y component is f of x1. So the idea of the method is join these 2 points by a straight line. So we consider the straight line joining these 2 points A and B. Now we find out the point where this line intersects x-axis. So we can see that the line intersects x-axis at this point, and we consider this point as our approximation to the root. Suppose we denote this point by x2, then we will consider x2 as approximation to the root of fx equal to 0. Now suppose we are not familiar or we don't know the graph of given function fx, then how to decide this point x2, or what is this point x2? So for that we can find out the equation of a line joining these 2 points A and B. We can decide the straight line passing through these 2 points, and then we can find out the point. We can find out this x2. Formula for x2 can be obtained by considering the line joining A and B, because this x2 lies on this line AB. So if we can decide the equation of line AB, then we can find out the value of x2. Now how to decide the equation of this line? So for that we can use the point slope form of a straight line. We are familiar with point slope form of a straight line. What is the point slope form of any straight line? So suppose we have a straight line with slope m, and suppose x1 y1 is any point on the line, then equation of line is y minus y1 equal to m times x minus x1. So here these 2 points A and B can help us to decide the slope of the line. So suppose we are interested in the slope of line AB, then it is equal to difference of y components divided by difference of x components, that is f of x1 minus f of x0 y components divided by x components, that is x1 minus x0. This is the slope of line AB. Now we require at least one point which is on the line. Here I have 2 points A and B which I know at the beginning, so I can use any point as this point y1 x1 to write down the equation of a line. Suppose I am using this point, then here I will put y1 equal to f of x0 in this equation, and this is equal to m times x1 means x component, that is x0. Now I substitute value of this m, y minus f of x0 equal to f of x1 minus f of x0 divided by x1 minus x0, and this is x minus x0. This is the equation of a line joining 2 points AB. Now this point x2, this point is also on this line, and we can see it is on x-axis, so components of this point are x2 comma y0. That means we can put x equal to x2 and y equal to 0 in this line, because this point x2 comma 0 is on this line, therefore it will satisfy the equation of this line. So I am putting y equal to 0 and x equal to x2. So I will have minus f of x0 equal to f of x1 minus f of x0 divided by x1 minus x0, and I replace x by x2 here, so I have x2 minus x0, and I am interested in the value of x2, so for that I transform this term on this side, and I first write down the formula for x2 minus x0, so that will be minus x1 minus x0 divided by f of x1 minus f of x0. This is multiplied with f of x0, and we are interested in the value of x2. So value of x2 is x0 minus x1 minus x0 divided by f of x1 minus f of x0 into f of x0. This is the approximation to the root, and we have obtained this formula for x2 using the line joining these 2 points A and B. After finding x2, we will find out value of function at point x2. If f of x2 equal to 0, then x2 is the root of given equation. But suppose f of x2 is non-zero, then either it can be positive or negative. Suppose f of x2 is negative, then this point is x2 comma f of x2. Now f of x2 is negative and f of x0 is also negative, so root cannot lie in this interval. So now root lies in between x2 and x1. So now what we are doing, we are repeating the same procedure. We will join the line, or we will draw the line joining these 2 points now, because f of x1 is positive and f of x2 is negative, so root lies between x2 and x1. So next approximation to the root is the intersecting point of this line with x-axis. So I join the line for these 2 points, be x1 f of x1 and x2 f of x2, and I will consider this point as my next approximation, that is x3. So x3 is the intersecting point of the line joining the point B and say C. So we consider this as our next approximation. So in this way, every time we will consider the line joining these 2 points and the intersecting point of that line with x-axis is our next approximation. So we will remember this formula, and suppose our root lies between x2 and x1. Suppose here our root lies between x2 and x1, then we can replace x0 by x2 in this formula. Here we can replace x0 by x2, we keep x1 as it is, and we will obtain next formula for x3. So we will follow this procedure to obtain the approximate value of root for given equation. What you have to remember is, you have to remember this formula: x2 equal to x0 minus x1 minus x0 divided by f of x1 minus f of x0 times f of x0. And if you don't want to cram this formula, you can derive this formula using this type of straight lines joining given points. So every time we are considering 2 points such that value of function is of opposite sign at those 2 points, then we consider the line joining those 2 points, and the intersecting point of that line with x-axis is our approximation to the root, and we repeat this procedure up to desired accuracy. So this is the idea of regular falsy method or method of false position. Sometimes they ask to discuss the particular method, so they can ask you the question that what do you know about regular falsy method or discuss bisection method. So you should write in this way. I have written systematically what I just discussed. Suppose we want to find root of fx equal to 0, then first step is to find 2 points x0 and x1 such that f of x0 and f of x1 are of opposite signs. So we can show by graph. Here I have considered 2 points x0 and x1 such that f of x0 is negative and f of x1 is positive. Now in the next step, we join these 2 points, point A and B, by the straight line. We join the 2 points x0 f of x0 and x1 f of x1 by a straight line and find where it cuts the x-axis. That is, we find out this point where this line cuts the x-axis. So suppose the line intersects x-axis at point x2, then the point x2 is the approximation to the root. Now we have discussed, or we have written, that how we obtain the formula for x2. So the equation of the line joining 2 points a x0 f of x0 and b x1 f of x1 is y minus f of x0 equal to slope of this line, that is difference between y components divided by difference between x components, into x minus x0. So here I have used this equation, y minus y1 equal to m times x minus x1, and I have taken this point x1 y1 as this point x0 comma f of x0. If you wish, you can consider this point also, there is no problem. In both the cases you will get the same answer. So here for this derivation I have taken my point in this equation as x0 comma f of x0, because this point is on the straight line, and this is the slope of the line joining these 2 points, that is difference of y components divided by difference of x components. Now this line is passing through the point x2 comma 0. We are considering this point because it is on x-axis, its y component is 0. So the point x2 0 is on this line, therefore we can replace y by 0 and x by x2. This point satisfies the equation of this line, therefore we can replace x by x2 and y by 0. So in the next step we have taken x equal to x2 and y equal to 0 in this equation, and after that we simplify. We first write down formula for x2 minus x0, and then we write down formula for x2. In the next step we find f of x2. Suppose f of x2 is negative, then the root lies between x2 and x1. So that I have shown here. We find out value of function at point x2, and suppose f of x2 is negative, then we have root between these 2 points x2 and x1. Because f of x0 is negative and f of x2 is also negative, we discard this part. Root cannot lie in this interval, Now root lies between x2 and x1. So in the next step, we find out the equation of line joining the points B and C, and the point where this line cuts the x-axis is taken as next approximation to the root. So that I have written here. We then join the points B and C by the straight line and find the point where it cuts the x-axis. That point is the next approximation to the root, and we continue this process until the root is found to the desired accuracy. So this is the idea of regular falsy method. We have to remember this formula, and if we are using this point bx1 f of x1 instead of this point, then also it is fine. You can use any of these 2 points, and using this formula we will find out the approximations to the root of given equation up to desired accuracy. In the next lecture we will discuss one problem on solving equation fx equal to 0 using method of false position or regular falsy method. So thanks for watching.